In these troubled times and throughout the free world, the Warsaw Pact nations continue to represent a powerful military threat, constantly increasing their numerical superiority and improving how they will fight and what they will fight with. By the mid-1980s, we can expect our potential enemies to deploy an armor force capable of moving with great strength against our defenses. Although the use of nuclear weapons cannot be discounted, most military analysts believe that should there be a battlefield confrontation, the primary challenge we will face must come from conventional weapons. A few years ago, intelligence sources indicated that a major advance of Soviet bloc nations was the development of armor capable of withstanding any of our anti-tank weapon systems. Armor that no existing NATO anti-armor defense could effectively defeat. To counter this emerging threat, there was a need to produce a new anti-armor weapon. Early in 1972, the U.S. Army Missile Command, MICOM, located at Redstone Arsenal, Alabama, was assigned this task. The challenge was met, and a missile possessing all the required capabilities is now a reality. Hellfire, an anti-armor missile capable of penetrating and destroying all present and future types of enemy armor. A missile designed as helicopter launched. Fire and forget. In other words, one launch, one hit, one kill. As work progressed, it became obvious that besides a stronger warhead, the project required a missile whose guidance system would eliminate pilot error. A major problem to be solved was how to allow a pilot to take evasive action against enemy ground fire, while at the same time keeping the launched missile locked on its target. One of MICOM's concepts is to use a ground-based laser beam as a target designator. The missile seeker is designed to automatically lock onto the laser-designated target. This allows the missile to be launched and permits the pilot to take evasive action at a considerable distance from enemy air defense weapons. With this capability, Hellfire is in fact a one-launch, one-kill anti-armor weapon. At Redstone Arsenal's McMorrow Labs, a number of different seekers and designators were tried out for operational performance. A moving terrain table is used to duplicate realistic battlefield conditions. This unique model landscape allows prototype missile system components to be evaluated in simulated operations against terrain targets in a variety of environments and tactical situations. Combined with highly sophisticated computer technology, the MICOM simulator provides an accurate analysis of missile guidance and control efficiency without having to commit a large sum of money for actual missile construction, hardware, and range tests. Following the simulated trials, the first full-scale missiles were produced and fired on the Redstone Arsenal test ranges. By 1982, Hellfire was recognized as the anti-armor missile to be mated with the Army's new AH-64 Advanced Attack Helicopter. Then, Hellfire was officially released for production. The Hellfire missile system is composed of 4 major subsystems. The propulsion unit, the missile's guidance and control system, the missile's shaped charge warhead, which is capable of penetrating and destroying any known Warsaw Pact nation armor, and the laser seeker. Hellfire is a modular missile system that allows its components to be changed and redesigned without having to alter the basic system configuration. Loading the Hellfire missile onto a helicopter has been made quick and easy. The launcher, also modular, can accommodate either a 2 or 4 rail carriage capacity. The launcher's adaptability enables Hellfire to be employed by other U.S. and Allied aircraft. These include the Army's Black Hawk, the original Hellfire testbed, the modified AH-1 Cobra, the Marine Corps' Sea Cobra, and the Air Force's A-10 aircraft. Future Hellfire applications may include other delivery modes and platforms. Operationally, Hellfire can be employed either by direct or indirect fire. With direct fire, there are several options which may be used. In this direct fire target engagement, the helicopter pilot is in communication with a forward observer, operating a remote ground laser designator that projects a coded laser spot onto the armored target. Prior to launch and throughout the missile's flight, the Hellfire seeker locks onto the laser spot. The guidance system's extreme accuracy ensures target impact, while the shaped warhead ensures target destruction. A second direct fire application is to locate the laser designator in scout helicopters. Acquisition of target and launch of the Hellfire missile are accomplished in the same manner as with the ground-based designator. The third direct fire option is known as the autonomous mode. In this application, the pilot himself designates the target and launches the missile without the use of a remote ground or airborne located laser. The second basic method of employing Hellfire is by indirect fire. Here, a remote ground laser designator marks the target with a coded laser beam. Even though the helicopter is in a masked position, that is, not in direct sight of the target, the launched missile finds the reflected laser energy and tracks it to an accurate target impact. Another Hellfire option is the ability to increase your firepower significantly by using either rapid fire or ripple fire. Rapid fire is an effective technique in both the remote and autonomous mode. In this remote mode illustration, enemy tanks have been observed moving to make probable contact with our deployed units. The Fire Direction Center requests attack helicopters carrying Hellfire missiles to be committed against the enemy tanks. A forward observer using a remote ground laser designates an approaching tank as a target with a coded laser spot. Using rapid fire, the first launched Hellfire missile locks onto the laser-coded spot and homes in on the designated target. 10 seconds later, and before the first target has been hit, a second missile is launched and follows the same laser target code as the first. But now, the ground laser designator shifts to tank number 2, causing the second missile to change course and home in on this new target. Using this rapid fire technique, it is possible to hit and destroy 5 tanks in about 60 seconds. The ripple fire technique offers even greater firepower effectiveness for Hellfire. Ripple fire can be used when our forces are confronted by multiple targets and when multiple laser designators are available. In this illustration, 2 laser designators, 1 ground and 1 airborne, are employed. Each designator operating on a different laser code marks a separate target. Hellfire missiles are launched in succession at both tank targets. Each missile then tracks its respective laser code and makes impact with its respective designated target. By combining rapid fire and ripple fire in one coordinated operation using remote laser designators, the results against enemy armor can be devastating and lethal. The modular design of the Hellfire D system allows follow-on seekers to be used. One example is an infrared imaging, or IRIS. In the autonomous mode launch, IRIS uses a heat signature to lock the missile on target. Then, with the missile launched, the pilot is free to take necessary evasive action as Hellfire proceeds to its objective. In addition to IRIS, Hellfire's modular system design will continue to be improved with the latest technological developments in advanced seekers and warheads. Therefore, in all respects, Hellfire should continue to meet its requirements: the ability to destroy any type of armor that may be fielded by our potential enemies. The modular Hellfire missile system. Adaptable. Versatile. Accurate and lethal. Hellfire is ready to be used by our armed forces. It is ready to perform. Hellfire. One launch, one hit, one kill armor destroyer.